All right, students, let's get into it. So this video is all about what we call the slope formula. All right? It's a way to calculate the slope looking at a data table. All right? So it's a new technique. So let's start with the definition. So like I said, it's used to calculate slope from two pairs of xy values from a table or a graph. So this could be a line of data in a table, or this could be a coordinate pair on a graph, a point on a graph. All right? So let's break this down. The actual formula itself looks like this. Okay? Now when you see something like that, that can be pronounced as y2 or y sub 2. Right? Anytime you see a small number like that, we call that sub, right? So y sub 2 minus y sub 1. I just call it y2 and y1, but they're both fine. All right, so the formula for slope, remember m is slope, is y2 minus y1 divided by x2 minus x1. All right? And I think what I will add to this are parentheses. Just so it's really clear, we subtract the values first and then we divide, right? Remember our order of operations, parentheses first. All right, so that's the formula. Let's look at it in actual practice, all right? So first, we're gonna start by just looking at a data table itself. So I made this one up. We have an X column and a Y column as usual. We have 4 rows of data, right? X values and their corresponding Y values. So when we decide to use the slope formula, we want to choose 2 rows of data or 2 points of data. And the big rule that you want to learn or you want to pay attention to is when you decide which 2 points you're going to use. Obviously, I'm deciding to use this pair and this pair. You always treat the top pair as x1 and y1, and anything below that as x2 and y2. So treat this just like, you know, the chronological order. This row comes before this row, so this would be x1 and this would be x2. All right? The hardest part about this formula is deciding which numbers go in which position. So it's really important you understand how to set this up. All right? So if you're looking at a data table, I chose 1 and 6 and 0 and 4. So I'm calling this x2, y2 and calling this x1, y1. And these arrows basically mean I'm subtracting these numbers from this number, right? This minus this, right? So let's look at what this looks like. So first thing I like to do is I just write, it's an extra step, but it really helps, is I define each of my variables, right? So specifically, what is x2? What is x1? What is y2? What is y1? This is a little technique that I do. It kind of feels like a little answer key, and this makes it really, really obvious what goes where, okay? So I recommend you do that. 1 is in the x2 position, so I called it x2, so forth and so on. Now it's pretty simple. I just take that formula and I replace x2 with 1. I replace x1 with 0, that kind of thing. And what I end up with is m equals, again, y2 is 6 minus y1, which is 4, over x2, which is 1, minus x1, which is 0. All right? I do simple subtraction. 6 minus 4 is 2. 1 minus 0 is 1. 2 over 1 equals positive 2. So if I were to plot these points and graph that line, the slope of that line would be 2. Rise 2, run 1. Okay? And that's it. When you look at a data table, that's it. Now let me just tell you, Did I have to do the first 2 points? No. You can do any points you want on a data table. The only rule is whatever comes first, that's the 1 position, and whatever comes after that is the 2 position. So could I have done 0 and 4 and 3 and 10? Absolutely. This would have been x2, this would have been y2. This number would have been different, but I promise you whatever I got here would have simplified to positive 2, right? Okay, let's look at the same data, but let's look at a graph version, okay? So take a moment, pause the video, draw this graph out. Very simple. I didn't label, there's no titles here, but we do know this is the x value, the x-axis, and this is the y-axis, all right? So once it's drawn, I just estimated my 4 points, right? x0, y4, x1, y6, x2, y8, x3, y10, right? So I just plotted those 4 points on this line, drew it up, okay? Now this time, instead of 0, 1, 1, 6, I decided to highlight 2, 8, and 3, 10, which are these 2 points right here. And I'm going to do the exact same equation. Now, I'm going to write out this pair of points, and I have to decide where my x1 is and where's my x2. And let's see if you see the logic. Okay, so there are my 2 points. And again, once I have my points written out, I do a little cheat sheet where I label each value so it's really, really obvious which number belongs to which part of the formula. That's really the hard part of algebra, is figuring out what number goes where when you're plugging stuff in. All right, so take your time in the beginning until you really get used to it. Now, why am I calling this point x1, y1? Well, if we look at our line, notice how this point was plotted first. This is the closest point to the origin, right? And then so then this one would be x2, y2, right? Whatever one comes first, going from left to right, that's going to be the first position, and then whatever comes next will be the second position. I want to make sure that's super, super clear, right? So just like here, whatever comes first in the order, that's the first position. Whatever point is first when you go farthest to the left, that's going to be your first position. Now again, can I use any 2 points I want? Absolutely. So decide which 2 points you want to use, write those coordinate pairs down, and decide which one goes in the first position and which one goes in the second. And the rest is just simple math, right? Simple math. y2, 10 minus y1, 8 equals 2. x2, 3 minus x1, 2. 3 minus 2 is 1. 2 over 1 simplifies to positive 2. Are we surprised these slopes are the same? Of course not, because it's the same data. It's the same line. It's the same slope. All right? So now you know by looking at data, by looking at a graph, or just by given 2 random points on a line, you can decide you can just figure out what the slope is. All right? Good work.